Hello there everyone and welcome to my channel. If you're new here, my name is Ahmed, and in this video I will be walking you through the solution for one of the tasks in Code Cloud Engineer. And I'm not affiliated in any ways with Code Cloud Engineer, but I do believe it's a valuable resource if you're looking forward to learn Kubernetes or practice it. So let's go through this task. This is actually a level 3 Kubernetes task, and this is currently task number 2. So I actually prepared a diagram for you in order to make it easy to understand the objectives of this task. So let's bring it up. So this is the diagram I prepared, and this is actually part of the presentation that I will be explaining to you in a moment. Let's take a look at the instructions and make a comparison with the diagram so that we understand what's going on and the flow of the process here. So first of all, this is an example of a LAMP stack on Kubernetes clusters. What does LAMP stack refer to? So L for Linux, A for Apache, M for MySQL, and P is for PHP. So let's start with number 1 here. We need to create a config map, which is PHP config. This is the name of the config map, and as you can see, it's located here. So this is the PHP config, which contains instructions related to how PHP must behave. The instructions or the configurations inside this config map will be mounted here in the Apache container, as we will see later on. Basically, the config map, which is named PHP config, is used to store the configuration for PHP settings, specifically this file, which is php.ini, and it stores it with the variables order settings indicated here. The variables order is to specify the method in which PHP registers and processes the different superglobal variables, which are here in the following order. So E is for environment variables, env, and G is for get, P is for post, C for cookie, and S for server. After that, we are asked to create a deployment named lamp-wp. This is step 2, and step 3 has more information about the containers that will be created when this deployment is built. So 2 and 3 can be seen here. So this is the deployment, which is lamp-wp, and it will be the replica set. Its replica set will be 1, so that it creates only one pod, and this pod contains, as per instructions, 2 containers. These containers are one for the application to hold the application in it, and the other is for the database. And HTTPD here is another name for the Apache. Usually it's HTTPD for Linux CentOS. And this is the MySQL, which is the database container. It's required to mount the PHP config, which is the config map that will be created in step 1. We need to mount it inside the Apache container, and it will be mounted at this path, which is the following one here. After that, we need to create a secret file for MySQL. It's basically to hold the MySQL related values. So this is the secret file. It's called the gensec, generic secret, and this file will be used to inject the environment variables into both containers. We then add the environment variables for both containers. This will take place in the deployment. We will see this in a moment. And here we need to create a NodePort type service. So 6 and 7 are to create services, one for the app container and the other is for the MySQL container, and you will see how to create this in the demo. The MySQL service is of ClusterIP type because it's not indicated here what type is the MySQL service. However, when it's not indicated, then we will set it to the default. It makes sense here because we need the MySQL service to connect only to MySQL container without any connection to outside the Kubernetes cluster. So we only need it to be accessed inside the cluster. Unlike the other service, which is the LAMP service, and this service is to expose the Apache app or the web application inside the Apache PHP container to the public, so the user will be able to access this application through a node port, which is this one. And we have the number here, 30,008. Therefore, the user will be able to access the app inside the Apache container through this port, which is the NodePort. So this is a NodePort service, and this is a ClusterIP service. After that, we need to move a file from the local machine, it's called index.php, into the PHP container or the app container. And the purpose for this index PHP file is to modify it inside the container and make it able to talk to the MySQL container through the MySQL service. We will see this also. We will see how to do this. So that's basically it. Let's go through the slides, and then I will leave you with the demo in order to see how this is done in the terminal, and you will be able to practice it. So this is the config map section. This is how you create it inside the file. Now the file I created is one file which includes all of the services, config map, generic secrets, and the deployment, of course. So you can do them separately, and I will be doing them separately in the demo. You will see how, or you can make them as one file and then create this file in Kubernetes. It's up to you how you'd like to do it. So this is how you create the config file. So this is the section for it. These are the data, and the kind is config map, and the name, we have to put the name as php config as per instructions. After we create the php config, we go ahead to build the deployment. These are the requirements for the deployment. You can also make it a part of one file. Now don't worry about all this information, you will see it clearly in the demo. So this section here, you have the kind, which is deployment, you have the name, which is lampwp. The template here is the template for the pod, and the pod will have the label, which is app lampwp. And this is exactly how the services will discover this pod. It's by the label. So we will see how to indicate or to specify the selectors in the services section. So yeah, this will build the deployment. The deployment will include one replica set as indicated here, and this is the template which will create the pod. The pod contains the app container, which has this name. These are the containers. This is the first one, which is this one, and the image of the Apache container. The environments that we will be adding later on, and we have also the MySQL container, which has the following image and the same environment variables as the first container, which is the Apache container. Of course, we include here the volume, which is the PHP config. So the config map is considered as a volume in Kubernetes, so we declare it as a volume, then we mount it into the first container, which is the requirement. This is the path, and then we need to include the sub path, which is php.ini. We then create the generic secret. We call it generic secret, gensec, which is the short term for generic secret. Now there are two ways to create it. You can create it this way or this way. From the command line, you can write kubectl. Now k is an alias because it's given to us that k, or you can actually create a shortcut for kubectl as k through alias. So kubectl create, and you create the secret, and the type of the secret is generic, and the name of the secret is this one here. And to insert the key value pairs, you include -- from literal, and you start by typing in the key pair values. The key here, for example, is the DB user and this is just a random value which I chose, and these are for the rest, password, DB name, etc. Now the other way to create it is through a file. Now of course this will create a file which will give you these values. What happens here is that the value is encoded in base 64. So this is why, for example, my user turns into this strange value. And the same is for my pass, which goes into the DB pass, so it's here. Now how to do this is actually by echo -n my user, then you write base 64. So this, when you do this, my user will be encoded into this value, and therefore if you're creating this as a section or a file, you can copy this value which is created and paste it here as a value for the key you want to use. So yep, this is for the generic secret. Now we move on to the services. So we have to create the services. We have the MySQL service, and as we said, this is a ClusterIP service, which is the default service, and you can see here that the ports used for this service, 3306 port is for the service, and the target port is for the container. So they are using the same port. The selector, as we talked before, it's app::lamp WP. This is the label of the pod, which contains both containers. So this service here knows what pod it will be serving, and because it has the port 3306 and the container here has the port 3306, it knows which container in the pod it will be serving. The same goes for the lamp service, which is the service required for the Apache container, which holds the web app. And as you can see here, there is the name is not required actually. So you have the NodePort, which is the port where the external user is able to access the app inside this container. So the user goes through this port, and this port takes him to the Apache PHP container through this service. Port is the port of the service, which is 80, and target port is the port of the container, which is 80. It's 80 because we didn't choose a container port in the deployment, and therefore the default number is 80 for port. However, it could be something else. It could be 8080. Sometimes you might see it, but it's fine. It's the same as the target port, and the port are the same. After that, this is the pod created from the deployment, and you will see it's generated by the lamp WP, which is the name of the deployment, and then there is a hash number which is specific for this pod. Now, whenever you update this deployment, redeploy it again, this hash number will change. We move on. After that, we enter into the pod, but before, we need to copy the index.php file, which is necessary to communicate with the MySQL container. So we copy it through this command. The file location is on the local machine at this directory. It's called index.php. You use kubectl-cp and then choose the destination, which is the pod, and you do not include pod actually because I don't know, it gives error. This is something related to how Kubernetes is built. Anyways, you will use the name of the pod, which is this one here, lamp WP, and the hash number, and then you put colon, you type colon and /app because it's required that it should be under the app directory. Probably it's configured this way, and type -c, which refers to the container you want to put this, or you want to copy this file into. So the container is the following container, which has this name. So we put it here, and now we haven't been given any message, so it indicates that the file is copied successfully. After that, we need to enter into the container to make some modifications to this file, which is index.php. So we use this command, exec-it pod. Now we use pod here /lamp, which is WP, lamp WP, and the hash of the pod, -c for the container, HTTPD, which is the name of the container here, and --sh, so that we access the shell inside the container. Now you can see when you list the files by ls, you see app, and then you cd into app, you go into the directory app, and then you list what's inside, and we only have the index.php file. We go into the file with vi index.php and we enter here. So as you can see, this is what we need to modify here. The DB host must be the server name for the MySQL service, because this is the service we need to connect to in order to reach the MySQL container. The DB user and the DB pass, in order to be verified, change these values into the following, and therefore we will be able to connect successfully to the web page. So what happens when you change this to the environment variables we created, you will be able to establish a connection from the container, or from the app inside the container, the Apache container, to the MySQL service, which will fetch the values from the MySQL container and return success or error. As a wrap up, this is the user accessing externally the web app through the node service, or through this NodePort. This NodePort takes the request to the LAMP service, and the LAMP service sends this request to the Apache web inside this Apache container. After that, the Apache container, because it contains the index.php file, which we already modified, now the Apache container knows how to reach MySQL service, because it's connecting to DB host, which is a standard from MySQL. It uses MySQL client, which is MySQL connect. And here we should include in the first place the server we're connecting to, which is the MySQL service. So it's connected to MySQL service, and then the MySQL service takes the request to the MySQL container and it fetches the necessary values. After that, the return is in the same direction. The request is returned as successful to the MySQL service, which also sends to the PHP or the Apache PHP container, and it takes it to the user in the same route. So that's it, folks. I'll leave you with a demo, and I hope you enjoyed this video. Please give it a thumbs up and let me know if there's something you're struggling with so that I can explain it more. Thank you very much for watching.